We're now recording.
Hi.
Hello.
Oh. So now you've got that off your mind. Should we get on? So we've got to use a prime factor method to find the HCF and LCM of 14 and 21. Okay. So we start with step 1. Find the prime factors. Find the prime factors using a tree. So before you write this down, let's do it. So what are the prime factors of 14? It's actually really quick and easy, this one.
Would it be 7 and 2?
Okay. Do you mind if I write it 2 times 7 like that?
No.
Do we stop? Are they both prime numbers?
Yes.
Okay. And then let's do 21, which is 3 and 7. Are they both prime numbers?
Yes.
Yeah. Okay. So there's the prime numbers. Step 2, put into the Venn diagram. Okay. Put into the Venn diagram. Now remember, I'll give you time to write this down afterwards. So let's do it together first. So how do I do the Venn diagram?
So you would do,
Abby?
you put on one side 14.
So a circle, like circle and circle.
Oh yeah.
This is 14, 21. So
And in the middle is the number, prime numbers that in common.
so the prime numbers that are in common, which is
7 and
the 7. So I've got the 7. That's the only one, isn't it? So I'm going to cross them out. So I've used it. The 2 goes here, and the 3 goes here. Okay. So Haji,
Yeah.
what is the highest common factor?
7.
7, because it's this 7 in the middle. Who can tell me how to work out the lowest common multiple? Taylor?
Okay.
How to rather than what it is.
By
No? You've got your notes. This is why we did another example.
multiply all the numbers.
Okay, go on then.
So 2 times 3 times 7 times 7.
No.
That just in the Venn diagram.
Just the 1 7, yeah. Just the 1 7. So 2 times 3 times 7.
2 times 3 is 6. 6 times 7 is 42. Sorry.
So that time is 42.
And then the answer is 42.
Good. Okay?
Thanks.
Okay. Okay.
Okay? Yeah? Cool.
Oh,
Right, one other thing then, before we get on. What do you want time to write that down, or have you kind of written that anyway? So you've already written. You want time? Okay. Okay. So, what if I now said, find the LCM and HCF of
Oh, okay.
9, 12, and 18. So 3 numbers. So, any ideas? What could you try and do?
So would you do?
We could see what number goes
So
into
you would
all
find
of
the
those.
prime factors of all of those.
Okay, let's try that. Let's see whether this method works here as well. So prime factors are
3 and 3.
3 and 3.
3 and 4.
So 3 and 4, but that then goes to 2 and 2,
And then that would be 2 and 9.
which goes to
3 and 3.
3 and 3. Okay, so we've got our prime factors of each number. Okay.
Step 2, draw a Venn diagram.
Okay, let's try and draw a Venn diagram, but we've got 3 numbers.
So it's a
kind of
tri.
like do 2 times 2.
So it's a tri diagram.
So we can. Let's just see whether the Venn diagram still works for us. It does work, but let's see.
It can, because then you can do one on the bottom.
Yeah. So we can have a 3-circle Venn diagram.
Well, I didn't know that was possible.
You can?
Possible, definitely. Yeah.
Oh.
Now, whether it's as easy for us now as doing 2 is debatable. We'll have a go at it, and if it doesn't quite work for us, maybe we'll find another way. But let's have a go.
It works because I did it highlighted.
You've done it in highlighters, so it has to work.
Yeah.
I've done it in
I really hope it works.
If this is one method,
My
I'll just
circles
write back
don't look
in
like
the-
circles from this angle.
They don't.
They don't.
They
do
look
they?
like
Really
squiggly
don't.
lines.
From where I'm stood at the side, it looks like, so I'll come over here. Right, so we've got, I'm going to put 9 there, 12 there, and 18 there. So where do the ones that are in each, so what's in each? So I've got a 3, a 3, and a 3. So where do you think that might go? So the one that has all common, so I can put a 3. Alright. There's nothing else that's common to all of them, is there? Oh, sorry.
No. Nothing else that's in common with all of them.
So 9, does 9 have anything left in common with 12?
No.
No.
No? So there's nothing in this region.
3.
Oh, no.
No? Does 9 have anything left in common with 18?
Yes.
2.
Yes. 2.
No.
No, 3.
A 3. So there's a 3, there's another 3. So this 3 could go there. Okay. Does that, or is that also in common with 18? Well, no, it's not, because we've
12 and
already dealt with that
18.
one. So
This
that
is
3 is gone.
confusing. 12 and 18 both have 2.
Right, so 12 and 18 share a 2.
And then,
So what should be put on the outside?
So what's left? So 9 now has nothing on its own. 12 still has a 2 there. And 18 has nothing. So what do you think the highest common factor of 9, 12 and 18 would be?
Would it be 3 times 3 times 2?
No.
Oh,
How did we do it before? The highest common factor
it
was
was the middle.
the middle. So do we think that's 3?
yeah,
Yeah.
that's what I was going to say.
Yeah. So the highest common factor we think would be 3. What do you think? Let's just check. 9. Well, the only factors of 9 are actually 1, 9, and 3. Now 9 is not a factor of 12, so actually that makes sense, doesn't it? 3 being highest common factor.
But 1 is also
What do you think then the lowest common multiple is going to be?
All of the stuff that's inside the Venn diagram.
So do we think 3 times 3 times 2 times 2 is 6? And what do you think? Does that work? So 9 times,
Yeah.
so 9 times 4 is 36. 12 times 3 is 36. And 18 times 2 is 36. So I reckon that's good as well. So it works. Yeah. So I'm just going to colour in that, and then that around there, and then this and this.
Wait,
So the lowest common multiple is everything inside.
I'm a little bit
Wait, the
confused.
highest common factor for the other Venn diagram we just did was.
So the highest common factor was that one there, wasn't it? So the highest common factor is the one that's in the middle of everything.
Can you just go back down?
Okay.
I will do, but we just answered the question. Yeah.
Okay, so for the 3 diagram,
Yeah.
so the middle section would be for 9 and 12. Like
The
that.
middle is for
Yeah.
all 3.
Oh, it's for all of the sections?
So yeah, so what I did look, if you notice that, first of all I said there was a 3, and a 3. So that went in the middle.
Yeah.
Yeah. So let me maybe try and work that out. Okay. So the blue ones all went in the middle because there's 3 of them. So it has to go in all 3 circles.
Yeah.
Okay. Then we looked at, well, is there anything in 9 and 18? And we said, well, there's a a 3 and a 3. So that was that 3. Okay? It can't be in the 12 as well because we've already done the thing that's in all 3. And then we looked at anything that was in 18 and 12. So we decided there was a 2 in 18 and 12. So that was this 2. Okay? And then there's nothing that's in 9 and 12. Therefore nothing there. And then we're left with only this. We're left with only this 2 left, which has to go in that.
Oh, okay.
Okay? Is that okay?
Yeah.
Got that?
Mm-hmm.
So we can actually extend this method for 3 numbers as well. Same rules, same method, you know.
What about 4?
Wait, so
Yeah,
the middle
four's
is what
bit-
all of them go into.
We're not going to go past it.
So the middle is what all of them go into.
Yeah.
And then like this side part is for like 9 and 18. And then this side part is for 12 and 18.
Yeah.
Oh, okay.
Exactly. I tell you what, do you want to do another one?
No.
Yeah, of course.
Yeah.
Okay. Do for me. So I would like you to have a go at finding the
Sorry.
the LCM and HCF of, let's make it harder for you. So let's do 16. Let's do 18 and 42.
Oh.
16, 18 and 42. Let's see whether you can apply this method for those 3 numbers.
Wait, so would we call this like a question? Just a question?
Yeah, so I would say find the LCM. So what, I should use my stamp, shouldn't I? Question.
Oh, okay. Oh yeah, that stamp actually does come handy.